Hello students, welcome to Short's classes. Today we will be talking about IIT JAM Chemistry question from 2018. So we will start with question number 18. Among the dimethyl cyclohexanes, which one can be obtained in inertia pure form? And we have 4 options given to us. So we have to choose from these 4 options. So this is basically a theoretical question and we have to know what is an inertia pure form first. So an inertia pure form is a form that is available in one specific enantiomeric form. It's a compound. So option number A is CH3. This is trans 1,2 dimethyl cyclohexane, and this one is present in an enantio pure form. So the answer will be option number A. So A is the correct answer. Moving on to the next question. So we have question number 20 in hand. The product is in the following reaction sequences, and we have a compound here and we have given reagents. The first is TiCl3 in ZnCu. So the second is cold alkaline KMnO4, and the third is H2SO4. So basically this is the compound we have. Double bond over here. We give TiCl3. This is the first reagent, TiCl3 ZnCu. So this will perform McMurray reaction and we will get a compound like this. So next we give cold alkaline KMnO4. So basically what happens now is a structure with a bond here and OH present here and another OH present here and a penting ring. So this is what we get. Now we apply H2SO4. This is 2, this is 3, and so here an H will be attached to this. So next we get this OH will be OH2 and a plus here, and this will remain same. Next we get this bond will come over here and subsequently a positive charge will develop over here. So we get a penting ring with a positive charge here and the OH present here and another penting ring. So this, now what happens is ring expansion occurs here. This bond comes over here and subsequently a positive charge develops over here. So we get the penting ring here with this ring expansion occurs in order to become a 6-membered ring, and we know that a 6-membered ring is the most stable because of the least angle strain. So this 5-membered ring becomes a 6-membered ring now. So this will look like this with a double bond though. This OH here is present, and subsequently we will have there are lone pairs present here, and this positive charge has been dissolved, but here the positive charge, this bond comes over here, so a positive charge develops over here. So this is the positive charge that has developed due to that, and this oxygen lone pair will neutralize this positive charge, and subsequently we will get a double bond O. So this will be a pentene ring attached to a 6-membered ring, hexane ring, with a double bond O present here. So the answer will be option number D. So the answer is D. Thank you.